student those are preparing the government exam like SSC JE, RRB JE, or states AE JE. PYQ or any previous year questions is very important for the crack any type of exams. So here we discuss everyday previous year questions. If you want to join with me, please first subscribe my channel, and on the bell, click on the notification bell, and for the get notified. Okay, already we have discussed 5 to 6 lectures. This is next lecture. Every day we practice the 25 MCQs. Mm, we are start from fluid mechanics. So we start 126 number questions. Water boils when its vapor pressure A equal that of the surroundings, B equals 760 mm of mercury, C equals to the atmospheric pressure, D equals to the pressure of the water in pressure. If you know the answer, please comment the answer. I give you a few seconds for the answer. Okay. A equal that of the surroundings. Let's check the explanation of these questions. In this book, every question's answers are explained in a very good manner or well manner. Water boils when its vapor pressure equal to that of the surroundings. The temperature at which liquids start boiling, called the boiling point of the temperature. Boiling point of the pure water is 100 degrees centigrade at atmospheric pressure. If the pressure of the atmosphere becomes 0.623 kilopascal, that the water start boiling at 0 degrees centigrade. Next question. For compressible fluids, density dash will change in the pressure and the temperature. A becomes 0, B do not change, C changes, D none of the options. Changes with the change in the pressure or temperature. Here is the explanation. For the compressible fluids, density change with the change in the pressure and the temperature. You increase the temperature, then decrease the density, and decrease the temperature, increase density, and the pressure is increased, the density is increased. So density is inversely proportional to the density, temperature inversely proportional to the density, and the pressure directly proportional to the density. Okay, density equal to mass per unit volume. At 4 degrees centigrade and 1 bar in atmospheric pressure, density of the water is maximum. Next question. Dash is not a property of fluid. Area, specific volume, specific weight, mass density. Area is not a property of fluid. Explanation is here. You can see that. Next question. The isothermal bulk modulus of a perfect gas at atmospheric pressure is. See the answer. I don't know the answer. Option A is the answer 1.013 into 10 to the power 5 Newton per meter square. Yani atmospheric pressure is 101,325 kilopascal or Newton per meter square. is equal to the atmospheric pressure. Remember it, the isothermal bulk modulus is the pressure is the atmospheric pressure 101,325 Pascal or 1.013 into 10 to the 5 Newton per meter square. An adiabatic process bulk modulus equal to density of the final pressure, any atmospheric pressure. The kinematic viscosity of a liquid is 6 strokes. What will be the kinematic viscosity in meter square per second? We know the one stroke equal to 10 to the minus 4 meter square per second. So into 10 to the minus 4. This is the answer. Kinematic viscosity is given that converted to the kinematic viscosity in meter square per second. The stroke is the CGS unit, centimeter square per second. Those are new in my channel, please subscribe in my channel uh, for practice daily. And those students who are not see the previous lectures, please go through the playlist and see the videos. Next question. In physics, fluid is a substance that is essential, incompressible, always moves when subject to shearing stresses, has a viscosity that always increases with temperature, has a viscosity that always decreases with temperature. B. Always moves when the subjected to the shearing stresses. Fluid is cannot resist the shear stress. You can see the explanation in the physics. The fluid is a substance that always moves when subjected to the shearing stresses. Types of fluid: Newtonian and non-Newtonian fluid, time dependent and the time independent. Time independent fluids are the dilated Winkel and the pseudoplastic fluid, time dependent thixotropic and the rheopatic fluid. Next question. The rate of shear strain for a liquid 10 second inverse and the coefficient of the viscosity of the liquid 0.5 Newton. Determine the shear stress developed in the liquid. We know the Newton's law of viscosity tau equal to mu du by dy. Rate of shear strain is given. Okay, so rate of shear strain is given. Put this here and coefficient of viscosity also given. You put in this here, then you get the shear stresses. Here is the explanation. You can see the explanation. As I told, there is the same way to solve this question. Next question. The space of the 20 mm between the two parallel vertical plates, yani y equal to is given 20 mm. The vertical plate is filled in the oil, viscosity mu is given. Determine the shear stresses of the wire and the displaced volume V equal to U equal to 1 meter per second. You put this equation, tau equal to mu du by dy, where du and u 20 mm 20 by du yani du yani 20 to 1 meter per second. Okay, and y is this and the mu is this. Then you put you solve it, then you get the shear stress 100 Newton per meter square. Next question. A liquid is compressed in a cylinder from a volume of 0.01 meter cube at 200 Newton per meter square pressure to the volume 0.01 meter cube at the 4 Newton per meter square Pascal. The bulk modulus of the elasticity. What is the formula of the bulk control elasticity? K equal to dp by dv by v. Here volume is the initial volume is 0.02. Change in volume 0.02 minus 0.01 and 0.01. A change in pressure 2000. 400 minus 200, so 200 approximately the answer is the 400 Newton per meter square. Let's see. Yes, 400 Newton per meter square. This is the process to solve this question. Next question. If the density of the liquid in 50 kg per meter cube, then the specific volume of the liquid. We know the specific volume equal to 1 by density. So density is given 50. 1 by 50 is the answer. If you solve that, you got the answer. Video complete. Then 1 by 50 means the answer is 0.02 meter cube per kg. Inviscid fluid is the fluid for which the viscosity is zero, or any non-viscous or the inviscous fluid. Next question. Paper pulp can be regarded as the dilatant fluid, pseudoplastic fluid, Newtonian fluid, and the Bingham plastic fluid. Paper pulp. Paper pulp is a pseudoplastic fluid. The explanation is here. Paper pulp can be regarded as the pseudoplastic fluid. This fluid is in the category of the non-Newtonian fluid. In the pseudoplastic fluid or the shear thinning fluid, or different types of the pseudoplastic fluids are blood, milk, cement solution, and the paper pulp, etc. Water is a Brinkmann fluid, hydrodynamic fluid, hydrostatic fluid, Newtonian fluid. Water is a Newtonian fluid. Newtonian fluid, those fluids follow the Newton's law of viscosity equation. For such, the fluid's dynamic viscosity does not change with the rate of the deformation, water, kerosene, air, etc. Next question, the relative density of a liquid matter is 2.5, then the volume of 1 liter liquid is 1 liter equal to 10 to the minus 3 meter cube. Okay. Relative density is given 2.5, then the volume of the volume equal to density equal to the density equal to mass per unit volume. So volume equal to mass per unit mass per unit density. You put the data in the equation, you can get the answer. Here is the also the process of the solving. Relative density is the density of the liquid by the density of the water. Mass equal to volume into density. So you get the 2.5 kg. Next question, what is the dynamic viscosity in the Pascal second for liquid having the relative density of the 0.85 and kinematic viscosity 2.5 centipoise? Pascal second and the unit is the centipoise. So it first you transfer this unit in the centistroke to centistroke, yani kinematic is centistroke to meter square per second. 1 stroke equal to 10 to the minus 4 centipose yani 10 to the minus 2, so 10 to the minus 6, 10 to the minus 6, 2.5 into 10 to the minus 6 is the kinematic viscosity, and the dynamic viscosity of the relative density is given. So The formula, we know that the kinematic viscosity nu equal to dynamic viscosity by density. So what is the dynamic viscosity? Dynamic viscosity mu equal to density into kinematic viscosity. If you put the data in this equation, you can get the answer. Here is solving the questions. Putting this data, the answer is given 2.1525 into 10 minus 3 Pascal second. Next question. Cavitation will become when the pressure at any location reaches and the absolute pressure equal to the standard vapor pressure of the liquid. Pressure becomes more than the critical pressure, flow in increased, flow pressure in increased. Um, A is the answer. The pressure at the any location reaches and the absolute pressure equal to the standard vapor pressure of the liquid. Explanation is here. When the pressure becomes the less than the saturated vapor pressure, then the due to the boiling bubble formation takes place and the cavitations occur. Next question. The predominant fluid property associated with the cavitation phenomenon is A. Surface tension, B. Vapor pressure, D. C. Mass density, D. Bulk modulus of the elasticity. B is the answer, vapor pressure. Let's check the answer. The cavitation phenomenon is related to the vapor pressure of the fluid. The formation, growth and the collapse of the vapor fluid on the cavities of the bubbles in the following liquid due to the local fall in the fluid pressure in the called the cavitation. The cavitation in a hydraulic machine affects in the following ways. It causes the noise and the vibration of the various parts. It makes the surface roughness, discharge of the reduced discharge of the turbine, and the it causes the sudden drop in the power output and the efficiency. In a vessel 4 meter given volume, the contains the oil and the weight 30 kilonewton. Specific weight. You know the specific weight equal to weight per unit volume. Weight per unit volume. So weight is 30 per unit volume. 30 into 10 to the 3 per unit volume 4. 4 short 7.5. C is the answer. You can see that. Next question. In SI unit of the SI unit of the dynamic viscosity. Dynamic viscosity SI unit is Pascal second. In Newton second per meter square. Is the answer. Next question. 100 meter cube equal to dash liter. We know that 1 liter equal to 10 to the power minus 3 meter. So 1 meter equal to 10 to the power 3 liter. Then into 10 to the power 2. 3 to the 10 to the power 5. D is the answer. Let's check the answer. Yes, D is the answer. Next question. An oil has the kinematic viscosity and the specific gravity 0.6. What is the dynamic viscosity? From the specific gravity we can calculate the density also. How to you find the density? You know the density equal to specific gravity into 1000 and 600 is the density. So kinematic viscosity is given. We know the dynamic viscosity equal to density into kinematic viscosity nu. If you multiply those, then you get the answer. Let's check the calculation. Here is the calculation. The answer is the 0.09 kg per meter second. Next question is the dynamic viscosity of the most liquid with rise in the temperature. Increases, decreases, remains unaffected, unpredictable. For the liquid, dynamic viscosity decreases with the increase in the temperature. Because the intermolecular attraction is the causes of the intermolecular bonds are the causes of the dynamic viscosity for the liquid. Explanation, you can read this. The velocity viscosity is also known as the absolute viscosity or the dynamic viscosity. It is defined as the property of a liquid which offers the resistance to the movement of one layer to the liquid over another adjacent layer of the liquid. The viscosity of liquid is due to the cohesion and the interaction between the particles. Most liquid with the rise in the temperature, the dynamic viscosity decreases. What is the following is a dimensionless quantity: kinematic viscosity, porosity, capacitance, illuminance. Check the answer. Porosity. What is the porosity? Porosity or the Biot fraction is the measure of the solid spaces in the material. Biot spaces on the material, and is a friction of the volume of the biots over the total volume between the 0 to 1 percentage is 0% to 100%. It is the dimensionless quantity. But the kinematic viscosity, capacitance, and the illuminants are not a dimensionless quantity. Next question: for the very great pressure, viscosity of the most gases and the liquids remains same. Sorry, remains not same. It increases. No, so erective behavior. That is the explanation. Effect the pressure on the viscosity for liquid. If the increase in the pressure or the decreases remains constant, approximate. For the liquid and gases, it increases. Next question: which of the following statement is not true? Fluids are capable of the flowing. Fluids conform to the shape of the containing vessels. When in the equilibrium, fluids cannot sustain tangential force. When in the equilibrium, fluid cannot sustain the shear forces. Fluid can sustain the shear forces. D is the not true. D is not true. Mm, we have already discussed 25 questions. So thank you for watching this video. If you are new in my channel, please subscribe and press on the notifications for getting the notification for new classes. Thank you.